You know, modern physics is kind of haunted. There are these three just colossal mysteries staring us in the face, but what if? What if dark matter, dark energy, and that weird little ghost particle, the neutrino, what if they aren't separate problems at all? What if they're actually breadcrumbs, leading us to one single revolutionary idea, one field that could literally rule them all? I mean, let's just stop and think about this for a second. It is an incredibly humbling fact. Everything we see, everything we've ever studied, every star, every planet, every galaxy, that's just 5% of what's out there. The other 95%? Well, we've given it some cool names, right? Dark matter, dark energy. But really, those are just fancy placeholders for a giant cosmic question mark. And that's where our story begins today. So, if we ever want to crack that 95%, we've got to face these three major puzzles head-on. These are the big, nagging questions that our best theory of the universe, the standard model, for all its success, it just can't seem to answer. First up, we've got the neutrino. This thing is the ultimate ghost particle. It's so light, so elusive, that right now, literally trillions of them are streaming through your body, and you don't feel a thing. But the really weird part? They shape-shift. They actually change their identity, their flavor, as they fly through space. They are the ultimate cosmic phantoms.
Okay, puzzle number 2. The case of the missing mass. When we look at galaxies, they are spinning so incredibly fast that, by all rights, they should have ripped themselves apart billions of years ago. Something invisible, some kind of cosmic glue, is holding them together with its gravity. We call it dark matter, but after decades of searching, nothing. It's a complete ghost in all of our detectors.
And finally, we have the runaway universe. It's not just that space is expanding. We've known that for a while. The shocking thing is that the expansion is speeding up. Something is out there hitting the cosmic gas pedal, pushing everything apart faster and faster. We call this force dark energy, and it's the most dominant thing in the entire universe. Yet we have absolutely no clue what it is.
So how does mainstream physics try to explain these three enormous problems? Well, the current approach kind of works, but it feels less like a single beautiful theory and a lot more like a series of patchwork fixes just taped together.
The standard view basically says, okay, we've got three problems, so we need three different solutions. So there's some new heavy particle for dark matter, and then there's a totally separate, mysterious force for dark energy. And neutrinos? Oh, they're just this weird exception that we kind of had to shoehorn into the model. It works, sure, but it's not exactly elegant, is it? And this is where a really radical new idea comes onto the scene. It's called the Harmonic Scale Framework, or HSF for short, and it just flips the whole script. It asks, what if these puzzles aren't problems we need to fix? What if they're actually clues, pointing to a much deeper, much more elegant reality?
In this question, right here, is the absolute core of the theory. What if we've been running around chasing three different phantoms when we should have been looking for one single entity that just happens to wear three different masks? This, my friends, is where things get really, really exciting. At the heart of SSF is this beautifully simple idea, one fundamental field that can have two completely different behaviors on a cosmic scale. This is the theory's big aha moment.
So, at the center of this whole thing is a proposed universal energy field. They call it the Neutrofield, or K4 if you're reading the technical papers. The best way to think about it is like a deep, invisible ocean of energy that fills all of space. It's like the universe's hidden energy reservoir, or its internal depot.
Now, check this out. This slide is the key to the whole thing. HSF proposes that when this neutrofield gets bound up and clumpy, localized in one spot, it acts exactly like dark matter. It provides that extra gravity we need. But when that same field is free and spread out smoothly across the universe, it acts like dark energy, pushing everything apart. It's the same field, just doing two different jobs depending on its state. So let's just let that sink in. The big takeaway here is that maybe we should stop searching for two completely different things. Maybe, instead, we're looking for one field in two different states, kind of like how water can be a liquid or it can be ice. It's a total paradigm shift in how we see the dark universe.
Okay, so that's a potential explanation for dark matter and dark energy. But you're probably wondering, what about our third phantom, the neutrino? Well, in this new theory, the neutrino is no longer some strange outlier. It actually becomes the star of the show. This quote from the research paper says it all perfectly. If the neutrofield is that deep, invisible ocean of energy,
that a neutrino is just a visible ripple on its surface. It's the only part of this entire hidden world that we can actually see.
And you can really see the shift here. The neutrino goes from being this weird, annoying patch in our theories to being a natural messenger from this deep underlying field. All of its strange behaviors are no longer mysteries. They're the expected fingerprints of the neutral field itself.
So how does a neutrino get created in this picture? It's actually incredibly simple. Imagine the neutrino field inside the sun is like an energy tank. The nuclear fusion going on is so violent that it just keeps overfilling the tank. Eventually, that excess energy has to escape, and it bursts out as a tiny wave of the K4 field. And that wave is a neutrino.
And this theory also beautifully explains all of the neutrinos' weird habits. Why are they so antisocial, so weakly interacting? Well, it's because they're made of this K4 field, which just doesn't talk to normal matter very much. Why are they so incredibly light? Because they're just a tiny ripple of energy. And why do they oscillate? Why do they shapeshift? Because they're just reflecting the natural vibrations, the harmonics of that underlying K4 field. It all just clicks into place.
So, what are the big implications of all this? If a theory like HSF is on the right track, it doesn't just solve some old puzzles. It gives us a completely new way to map the entire universe.
And this, for me, is the most mind-blowing part. If neutrinos really are messengers from the hidden 95% of the cosmos, then studying them is like learning to read a brand new cosmic language. We could finally see the dark universe just by listening to the whispers of neutrinos.
And this is absolutely crucial. As you can see here, this isn't just a neat story. HSF makes real, testable predictions. A good scientific theory has to stick its neck out. For example, it predicts that neutrinos should behave differently depending on whether they travel through empty space or a dense halo of a galaxy. These are things our telescopes and detectors can actually look for, which means this theory can be tested and either proven right or wrong.
And it all just boils down to this, the stunning, elegant possibility of solving the three greatest puzzles in all of physics with one single idea, one field to explain it all.
So, we're left with this really profound question. For decades, we've seen these mysteries as separate, clashing notes, a dissonance in our understanding of the cosmos. But what if they're not problems at all? What if they're actually different notes in a single, beautiful, cosmic harmony that we are only just now, finally, learning how to hear?